Hello, in this video, we will introduce the algorithm for finding shortest path. The algorithm we are going to use is by Decaustrous. So this is called the Decaustrous algorithm. This algorithm finds the shortest path from a source vertex to all the vertices. So you want to find the vertices from A to B, but along the process, you discover the shortest path from A to all the other vertices. We're going to use a very similar algorithm to the previous algorithm for finding minimum spanning tree, but there's a subtle differences. So let's look at this algorithm here. And this is the algorithm, and the input is a graph with non-negative weights and a source vertex S. And the output is a shortest path tree with the source vertex as the root. So the return from this function, get shortest path S, is the shortest path tree. Let T be a set that contains the vertices whose paths to S are known. We discovered it. So this is now in T, the shortest path tree here. So we're going to add it to T. So all this are the vertices. Their path to the source is now discovered. Set cost V to infinity for all the vertices, and set cost S, the starting vertex, to 0. So 0, the S to itself is the shortest distance is 0. And set the parent of S to -1 to denote that this is going to be the root in the shortest path tree. While size of T is less than N, so we're going to discover the next one here. Find U not in T with the smallest cost U, add U to T. For each U not in T and UV, this is HV is adjacent to U. We're going to look at this. The cost of V is if it's greater than cost of U plus this H. So here, this V is going to go, this one here is the cost now. The current one, this V to S, is more costly than this new path going through U. So then we're going to set this new cost for V is cost U plus this H, the weight of UV, and set the parent of V to U. All right, so let's walk through this diagram here. And here is the T. So we're going to keep adding the vertices to T. Initially, T is empty. So we have, initially T contains only the S. So you are going to see that in this case here, we discover that the U is the lowest cost. We're going to add U here. And after you add U here, you're going to look at the V1 and the V2, see if you have to make any change on the cost for V1 and V2. So now let's look at this example here. We're going to start from this 1 now. So look, right now the cost is 0 for 1. So we're going to add 1 to this T. So next, the smallest cost is 2. So this is 5 here. So we add 2 to T. And after this, we're going to adjust the cost for 0 now becomes 6. So it was 8, now it's a 6. So going through 2 to 1 is shorter than going from 0 to 1 directly. And after this, look which one is, this is 0. We're going to add 0 now. 0 is the lowest cost. And so we make adjustment for this 6 is now becoming this, the cost, this for 6 is 8. So it was 9, so now it's 8. And so we're gonna pick this 6 now, next. And after this, we're gonna pick the, any of this 3 or 5. So 3 or 5. So let's pick 3. And we're going to adjust the cost for the 4 and the 5. So this is the 4 is now 18 and 5 is 10. So now we're going to pick 5. So after you pick 5, you're going to adjust this is, and this is for 4 is, this now is 15. So 4 is going to go 5. So that's previously 4 is 18. So this is 4 is 15. So now finally, and 4 is going to go through 5. So this is the algorithm. And here is the shortest path tree. It's a subtype of tree. And you have the cost for this, total cost. And this is the cost is for every vertex in the tree, you have a cost. So that is the cost, the shortest path from the source to that vertex. So this is constructor. And here you have another constructor here. You constructed the tree using the source, parent, and here's the search order. And this is the cost vector. So this is the get cost for each vertex. So here is the shortest path tree. So this is the shortest path tree. It's the subtype of tree. And here is to get the cost of each. So this is cost V. So let's look at the implementation of this. It's implemented in listing 27.2. So look at starting from here, it is the get shortest path, and this is source vertex, and the this is the T. So initially it's empty, and this is the parent, and this is the source vertex. Now it is, the parent is -1, and here we have the cost. It's the vector, the size of the cost, get size. And this is the initially, or this is the infinitive, and now cost for the source vertex is 0. So we're gonna expand the T, and T is, the size of T is less than the size of the graph. So we're gonna find one more to add into T. So this is find the smallest cost. So we're gonna find the smallest cost here, U. So now push it into T, and now adjust the cost for the neighbors of T, which are not in the T. So finally, after this all done, we're going to return shortest path with the source vertex, parent, and this is T. T is the order of all the vertices discovered. And so this is now the cost. That is all for the algorithm and implementation of the algorithm. So here is a test program, shortest path. So we have this is the print all path, and this is my vertices here, and this is the edges using that the map graph, and here. So, and this is to get the vertex and vector of vertices, and this is to get the edge vertex. So create a graph 1. So now we get the shortest path for this 5 here. And so now we will get the print all the passes starting from this 5 to 0. And here is example for another graph. And this is to create graph 2 and get the shortest path to all the vertices. So that is all for this section on finding shortest path. See you on the next video.